again, I'm not going to recopy this. You can see the formulas on the pink sheet. Okay? So like I said, all you have to know for the double angle identities is how to work them using the reference triangles. All right, so let's take a look at number 1. Find the sine of 2 theta, cosine 2 theta, and tangent 2 theta, given the cosine of theta is negative 5 over 13, and theta is between pi and 3 pi over 2. So first of all, what's the location of this triangle going to be? 3. Because again, pi to 3 pi over 2 is in quadrant 3. Cosine I know is the adjacent over the hypotenuse. So the adjacent side is 5, the hypotenuse is 13. What side gets the negative sign, by the way? 5. So if you don't recognize this as one of your Pythagorean triples, you'd have to use your Pythagorean theorem. But what's the adjacent side going to be? Yes. So.
Are you ever going to have a negative hypotenuse?
Nope. Hypotenuse is always positive because you're squaring the adjacent and the hypotenuse side. So any questions on the setup? So now to find the sine of 2 theta, from your pink sheet, it's 2 sine theta, cosine theta. So from my triangle, I'm going to fill in the sine ratio. What's the sine ratio from this triangle? The sine is going to be what? Negative 12 over 13. Cosine is going to be the adjacent over the hypotenuse, which is negative 5 over 13. Remind me again, what's this denominator for 2? 1. So now how am I going to multiply these 3 fractions together? I'm simply just going to multiply what? Straight across. So 2 times negative 12 is going to be a negative 24. Negative 24 times a negative 5, well, I know a negative times a negative is a positive. So a negative 24 times 5 is going to give me 120. 1 times 13 is going to give me 169. So there's your sine of 2 theta. So any questions on how I found the sine of 2 theta? So now the cosine of 2 theta, ladies and gentlemen, you actually have 3 variations. Eeny, meeny, miny, mo, it doesn't matter which one you pick. I always like to use the first one, the cosine squared minus the sine squared. So again, from my triangle, the cosine I know is negative 5 over 13. So when you see that cosine squared, what you're going to do is you find the cosine ratio and you just square it. Minus sine squared, again, sine is going to be the opposite over hypotenuse, and that's a negative 12 over 13 squared. Remember, when you square a fraction, you square the numerator and you square the denominator. So negative 5 over 13 squared is going to give me a what? 25 over 169. Minus, when I square negative 12 over 13, that's going to give me a 144 over 169. Watch your signs. What's 25 minus 144? Negative 119 over 169. So any questions on using the double angle formula for sine or cosine? Tangent. Remember, the tangent of 2 theta is just taking the sine of 2 theta, dividing it by the cosine of 2 theta. Well, we found the sine of 2 theta already, which was 120 over 169. And then I'm going to divide this by negative 119 over 169. There's a reason why I wrote this out horizontally. How do you divide fractions? You're simply going to do what? You're going to multiply by the reciprocal. So the tangent of 2 theta then is going to be 120 over 169 times 169, watch your negative, over 119. So that's going to give me negative 120 over 119. So if you can find the sine of 2 theta and you can find the cosine of 2 theta, then the tangent of 2 theta, you just divide those 2 ratios. All right, any questions on example 1? If you you guys go ahead and see if you can get the triangle set up for example 2 for me. Any questions, guys, on how I set up the triangle? All right, now see if you guys can go ahead and find the sine of 2 theta for me. So again, remember the sine of 2 theta is 2 times sine theta cosine theta. So see if you can find this sine of 2 theta for me. Work these formulas, the radicals will take care of themselves like you can see they do in this one. So any questions on where I got 4 over 5 from?
Oh.
So again, remember the sine is going to be negative 1 over square root 5. The cosine is negative 2 over square root 5. So when I multiply straight across, 2 times negative 1 is negative 2, and then negative 2 times negative 2 is a 4. And then square root 5 times square root 5 is going to be a 5 in the denominator. Any questions on where I got that? Yes, Ian, please. Any questions where I got that from?
For the denominator, didn't you get 2 square root 5?
No, because remember you multiply. You're not 2 square root 5 would happen if you added those denominators together, but you're multiplying them. So square root 5 times square root 5 is actually a square root of 25, which would just give you a 5. Guys, go ahead and see if you can find the cosine of 2 theta. Again, cosine of 2 theta, remember from your pink sheet, is cosine squared theta minus sine squared theta. So you set up the cosine ratio and you square the fraction. You set up the sine ratio and then you square it. And hopefully everybody came up with 3/5. Okay, so any questions, guys? So I think the double angle formulas are a little bit actually easier to use than the sum and difference formulas. But like I said, it's just making sure you can set up those triangles and find the sine and cosine ratios and plug them into the correct formula. Any questions on that one? Now remember, the tangent double angle, remember I'm simply going to take the sine of 2 theta and divide it by the cosine of 2 theta. So remember, I found the sine of 2 theta to be 4/5. I need to divide it by the cosine ratio, which is 3/5. So again, how do I divide fractions? I'm simply going to multiply by the reciprocal. So 4/5 times 5/3 is going to give me a 4/3. So any questions on the sine or cosine or tangent double angle formulas? So all you have to be able to do with the double angle formulas is work them from the reference triangles. All right, so any questions on that? Again, most of the time is going to be spent making sure you have memorized the double angle formulas. All right, again, tangent's just the sine of 2 theta over cosine of 2 theta. All right, and again, once you do these enough for the homework, you probably will have them memorized before you're done. All right, so any questions on that? All right, so that's it. We are done Unit 3.